Good morning, good afternoon, and good evening, wherever you are. Thank you for joining. At CIQ, we're focused on powering the next generation of software infrastructure, leveraging the capabilities of cloud, hyperscale, and HPC. From research to the enterprise, our customers rely on us for the ultimate Rocky Linux, Warewulf, and Apptainer support escalation. We provide deep development capabilities and solutions, all delivered in the collaborative spirit of open source.
Yes.
Good afternoon.
Good evening.
Good afternoon here. Yeah, morning.
Good morning. Oh, you know what? That will just never get old to me. You will never live it down. I love it.
know.
Everywhere I go, I hear you in my mind. And then also the music.
It's been like a year and a half of doing that now. You realize that?
Wow. Wait, bring that back up. Bring that back up. I can be in my wow and read Jonathan's little note at the same time. What did that say? Let's see if Brian can make a cluster in the time it takes me to take my coffee.
Sounds like a challenge, Brian.
No pressure, right? No pressure. Build me a cluster.
No pressure.
That's awesome. So glad that you're here, Brian. Thank you so much. This was honestly, I mean, this was totally last minute. We're like, what would be a cool webinar idea? We're like, Brian's done it. And of course, in my like cluster ignorance, I'm like, yeah, it'll be fun. We're just gonna do it. And he's like, but wait, what do you
No pressure, no prep.
It's all
Close the cluster, Brian. Do it now.
It's all good. So what I've prepared today was I was thinking we could cover maybe just a basic architecture of a Warewulf cluster and talk about why Warewulf, why Apptainer, why Rocky, and then we can go into. I prepared a brief demo of how to set up Apptainer fake root on a Warewulf cluster. So I can go through that type of demo, and if we have time at the end, maybe we can talk about just performance of different workflows on this stack, and if it applies to whatever industry vertical we can talk about. Maybe we can leave it to the audience to suggest one, and yeah, kind of go from there.
Yeah, I love it. This is really amazing, Brian. I mean, I mean, I know that you know, but so many people come to us with all different kinds of environments, wanting to kind of maybe save a little money getting out of the cloud, and you know they're buying some hardware, and they're like, okay, like now that I just have this incredible investment in hardware, what do I do? How do I put it together properly? So this is very exciting, Brian. Appreciate it.
Cool. And I guess related to that, I guess a performance of your workflow, yeah, it is really dependent on the type of hardware you're buying. But I feel like with Warewulf, it just gives you a very easy way of just provisioning your cluster just to get it up so that you are able to at least benchmark your workflows and figure out how they work and really optimize them to where you're getting peak efficiency out of your system.
Yeah, and I feel like, Brian, I hope you cover this a little bit, but having some of those people that have come to us that you've worked with specifically that are bringing older hardware and new hardware together. So I have this old thing that doesn't necessarily function the way that I want it to, and building that into something that they can make far more usable. So
for sure,
it's awesome. Looking forward to it.
Cool. So I guess let's jump into I guess a basic just cluster architecture. So if I share my screen here, can y'all see that?
Got
cool.
it.
So this is kind of the architecture that we're working with in our HPC lab. So how I've set up this environment is we have a head node that's connected to some external network that I'm going to be SSHing into. This head node is connected to an internal cluster network, which Warewulf will be doing provisioning on, and the various Slurm services are also running on this internal cluster network. Not in this environment, but this is very typical with on-prem environments, as you'd also have an IPMI network. What this is meant to do is this enables you to control your compute nodes from your head node and be able to power them on and off without actually going into your data center and hitting a button, which makes it really convenient. And I've, if you're a sysadmin, you know the feeling of having to go into the data center and actually hit a button is very annoying. And, if this is a way to prevent you from having to do that. And then lastly, as part of this environment, we just have a compute node that is running slurmd. This is basically the Slurm client, which will talk to the controller to either basically accept work and communicate with the controller. And there's one more service that I have on here that I didn't mention. Slurm DVD is basically the Slurm database daemon. This database daemon is basically responsible for writing job accounting data to a MySQL or MariaDB database. And it also can store job completion data as well. So you would want to run this in your environment if you want to do some reporting on the usage of your cluster, stuff like that. And by being able to generate these reports, you can take these reports, show them to your management, and show them the value that your equipment is actually delivering for your organization.
So real quick, Brian, I know the title of this is Rocky, Apptainer, Warewulf. I know we have stuff up here about Slurm. Do you want to give just a real quick, I know you talked about what from a reporting perspective, you want to just kind of real quick, high level, what is Slurm?
Yeah, so Slurm is basically a workflow scheduler. So basically it offers an interface for users to submit workflows either in batch mode or interactively, and have these workflows run on your compute cluster. And basically Slurm has like a lot of features where you could optimize Slurm configuration for your workflows, whether it's from setting resource limits, implementing access policies, all that type of stuff can be implemented in Slurm and also tracked as well.
Thank you.
Cool. So I guess moving on to the next part. So that basically covers the architecture of what we're kind of working with today. Let me just stop my screen share real quick. And I guess we can talk about maybe why Warewulf, why Slurm, or why Apptainer, and I guess why Rocky. I guess let's start with Warewulf, I guess. Warewulf is a OS provisioning tool, and basically can be used to provision a high performance computing cluster. And I guess viewers might be asking, why would you even want this, right? Why do I need a OS provisioning tool, and why would it benefit me? And I think the story that I'm reminded of is Greg telling the story, our CEO Greg Kurtzer telling the story of debugging I think the root cause of an issue related to a node he was working with was it came down to power on a node. But without having your nodes consistent, you wouldn't have been able to kind of figure this out. And I guess Warewulf is a way of ensuring that what you're deploying to your nodes is consistent and is documented, and basically you're basically removing all of these variables so that you can actually debug these low-level problems, basically. With Warewulf, specifically Warewulf v4, some of the cool features that come with this are that your node images are basically containers. So because they're containers, you can build them in a CI pipeline, have these written to your some container registry. If you want to do security scanning on your registry, you can do that before these node images get deployed onto your cluster. And so in addition to that, in addition to the node image aspect of Warewulf, Warewulf has the concept of overlays. And overlays are basically configuration files that get applied to your compute node after it's been provisioned and before your services basically start up. Warewulf has the concept of system overlays and runtime overlays. System overlays get provisioned once at boot time. Runtime overlays periodically get updated. So if you want to make a change, that's part of a runtime overlay. It should be deployed to your new node or to your compute node within a minute. So it makes it really easy to push out these changes to your compute nodes.
So we have a question, but I'm going to ask you a question before we go to that one. Thanks for the question, Sumit. We get asked quite often whenever we talk about Warewulf pushing to a compute node as a container. I get people that are asking, are you actually running a container on an existing operating system, or is it the definition that then gets turned into an actual operating system and run somehow?
It is so basically, I believe how this works is we're basically building a container with a kernel in it, and this container gets pulled to the compute node as part of the Pixie boot process. And we're basically booting off the kernel that's within the container. So when your compute node actually comes up, you're basically running on bare metal and not within a container. Yeah. And it's more a means of provisioning your operating system, but not actually running within a container.
Makes it very clean.
Yes. Cool.
So there we go. How is CIQ different from Bright Cluster Manager?
Ooh.
It's a good one.
I think mainly
it's Warewulf.
I think mainly with Warewulf. Well, CIQ it supports Warewulf, and basically Warewulf is, I believe, I haven't worked with Bright in a while, but I believe Bright does stateful provisioning where Warewulf is stateless, and I believe last time I used Bright, I believe they're still using. You had to build your images, I guess, in Cheroots versus Warewulf, where we're just using container files. You're able to pull these node images in from registries, stuff like that. We also, speaking of those containers, we have base Linux containers in a Warewulf node images repo. So if you want just a Warewulf bootable container that you want to pull from GitHub, you can visit that repo and be able to get up and running really easily.
Thank you for the question.
Yeah. So
that seems to come up quite a bit. That's why Rose is chuckling. We hear, how is this different than Bright? Seems like every day.
So I think those are, I guess, the main points I had on Warewulf. I guess we can move on to kind of Apptainer and why you would want to use that on your cluster. I guess from a user perspective, this Apptainer has the feature of fake root. And as a user, if you're a scientist, you're trying to install software. I guess the old way of, or how this would typically be done is, you need to contact your HPC sysadmin. They have to install the software for you. And then there's all this back and forth of, hey, did you test it? Oh, it doesn't work. And then you end up with this back and forth. But with Apptainer, the beauty of it is with this fake root feature, users can just install packages in kind of a sandbox environment. And, if you mess up your container, you can delete it, you can build a new one, and you can move a lot faster without having to do all this back and forth with your system administrator. And it really puts the power of being able to do science in the scientist's hands, basically. Some of the performance benefits of using Apptainer from like a technical perspective, especially if you're running, Python packages, stuff like that. If you're doing that over NFS, typically there are a lot of metadata operations when your job is starting up, which may affect your job startup time. By having these packages all within a container, these metadata operations become file seeks, which will result in your job starting a lot faster, basically. And job starting faster is, I think, a really good benefit. And you can get your results faster. Get those results into your paper. All that good stuff. Yeah. Cool.
So I think one of the questions we get a lot too, Brian, is why not just use Podman or Docker?
I think with so the nice thing with Apptainer is that your container is basically just a file on the file system, which makes moving your workflow a lot more portable. And I think that is one of the biggest benefits of it. And whether you're on your school's system, you can take that container, move it to the cloud, and you can ensure that your software will still work on the cloud as well. Yeah.
Thank you.
Cool. So I guess we can jump into a demo if
let's do it.
Everyone's ready. All right, so let's.
No,
Jonathan has got his coffee, so he's.
It's not fair. He hadn't even started yet. You have to have a second cup, Jonathan.
Coffee is done. Oh, that's awesome.
All right.
So I guess also, I mean, what does Warewulf run on any operating system? I mean, obviously we want to highlight Rocky, but does it really matter as long as it's Linux, or can it be anything?
I believe this Rocky can be installed on any RPM based Linux distro. I believe at the moment. Yeah.
You mean Warewulf?
So, oh yes, Warewulf.
He's thinking
I'm like, wait
containers,
a minute,
and on
my
top
brain
of this
is like
thing.
trying to figure that one out. Yeah.
All right. So with this demo that I've prepared, I'm basically going to demonstrate Apptainer. So I'm going to demonstrate getting Apptainer fake root working on a Warewulf managed compute node. So is my font size okay?
No, I don't think. I mean, I have my glasses on, and I would love
bigger?
it to be quite a bit bigger.
All right, let's do that.
A little bit more. Yeah.
Okay.
That's
So
better.
on this bottom prompt, I basically just set up a test user, and within this cluster, I have Slurm running. So if I do an sinfo here, you can see I have one node up, HPC Lab Compute 0. So as a user on a cluster, something I would try to do is set up a interactive job which lands me onto a compute node so that I could try, maybe building my software and testing it out on some of my data. And this is just for testing purposes before I start launching a bunch of workflows into the cluster. And I just want to make sure my stuff works and that my software is working. So the typical workflow that I would do is I would start off with a interactive job, and this should put me on compute node 0. And right now I am going to try to do, and if we take a look in my home directory, I basically have this Warewulf Rocky Linux 8 container that I'm just going to try to shell into with fake root. So shell, and let's add a fake root here. Or first we can start with just showing into it normally. If we do who am I, you can see that I'm the same user. So if I exit out of this and I try to use fake root, it gives me a warning that I basically don't have a user mapping for this user in /etc sub UID basically. And the purpose of this demo is to show you how to get these files basically onto your compute nodes through Warewulf. And because I don't have this user mapping, I don't have basically in the fake root context that I'm in right now, it doesn't have the full capability of Apptainer's rootless, I guess, feature basically. So let's back out of this. I'm just going to exit and let's get out of this interactive job, and let's see how I'm actually going to implement this. So taking a look into Warewulf now, I basically have this overlay set up called Apptainer fake root. And within this overlay, I basically have /etc sub UID and sub GID with this .ww suffix on it. And you might be wondering, what is the suffix on this file? The suffix basically denotes that this file is a Warewulf template. So let's actually take a look at what this template actually is. So if I cat this file, and let's just take a look at some. And basically catting this file within this overlay, you can see that I have this line which includes the file on this specific file on my controller node. And if we take a look at that actual file on my controller node, we can see that we have a mapping for test user that's already here. So by having this file on my compute node, I should be able to use the full featured fake root feature. So to do that, let's first so I also want to show you the node that I am, the compute node within Warewulf as well. So as you can see here, what I would like to point out in this line here is the runtime overlays are coming from this default node profile, which currently just contains the generic overlay, which contains things like your users, your groups, and all that type of stuff. So how do we actually get this overlay onto the node? So to do that, I am going to add this overlay as a runtime overlay on the default node profile. So to do that, we are going to do set, and then I'm going to add Apptainer fake root. So I'm going to run this Warewulf control profile set command, which will set the runtime overlays of the default profile to generic and Apptainer fake root. So do that. It'll ask me to confirm. Yes. So I also want to show you, you can also see what runtime overlays your compute nodes are pulling by running the Warewulf node status command. And as you can see, HPC lab compute node 0 is pulling a runtime overlay, which just contains this generic overlay. So after I've set this overlay, runtime overlay on the profile, I can quickly rebuild that overlay for my compute nodes. And we can, and because this is part of a runtime overlay, we can actually watch. Oh, okay. So as you can see, because this is a runtime overlay, we can see that this has already been pulled. And on this compute node now, it's pulled the generic and Apptainer fake root overlay. So if we jump back to our test user now, if we do another we just start off another interactive job, and then we can hit it with that fake root command again. And now you can see I no longer have that warning of the UI sub UID not being mapped. And I'm not seeing that warning with my user not being in the sub UID mapping. So I can get out of that, and wonder if this will work. So UID, yep. And as you can see, the same file that's on the head node is now consistent with the file that's on my compute node. Cool.
Very nice.
Yeah. So, yeah. And yeah, I guess I could pause there for any questions we might have. Anything coming in from the comments or?
Yeah, Submit does have another question.
Cool. We are required to get every software approved by our universities. Do your containers comply with some security standards?
I feel like we need a little bit more detail on exactly what that is.
I think what we would need to know what type of standards I guess you're trying to meet, and I think we can work from there. Yeah.
Yeah, I'm assuming it means the ones that are getting pushed out to the compute nodes. So as long as you define that in your container to be the image that you need it to be and meet whatever policies you're trying to meet, then the answer should be yes.
Yes. Cool.
Well, that should be pretty easy if you know what you're looking for, because containers, specifically Apptainer, you can sign them cryptographically, right? Like, so you know where they came from. Is that like a helpful feature for this specifically, or are we talking about something different?
I'm wondering if he means the actual operating system running on the compute node. So it might be a little bit different, but to your point, if you're talking about the container specific side, then as long as your container is running something that meets whatever security standard you need, yes, you can encrypt that as well.
Yep. Cool.
Right. You kind of know where it comes from. I mean, that's kind of like one of the benefits that CIQ provides as well, right? Is through one of our products named Mountain, you can have, your signed images, Apptainer images in there, so you know exactly where it comes from and it's verified. Not important for some, very important for others.
Yes, totally.
Good point, Rose.
Cool. And I guess we can kind of segue into, our last topic of just running workflows that work well on the stack. I mean, in general, I feel like the stack can basically run any workflow, but when it comes down to for like performance, I think it really comes down to the type of hardware that you're running on, and also how your scheduler is also configured to actually orchestrate these workloads in an efficient manner, so that you're getting the best time to results. I can kind of expand on that. I think it's different I feel like for different like industry verticals. But if there's a specific industry vertical that you'd like me to talk about, yeah, I'm open to any. Any suggestions?
So Brian, on the different stacks, doing it, if you look at it and think about it that way, if I have two different types of science that I'm doing in the same cluster with Warewulf, I could actually push different images as that executes or as I need them. Like I'm going to do this type of workload, I can make everything on the cluster, its compute node this, and then I can quickly move it to something else to execute a different type of job, right?
Yeah. So I think let's see. Let me try to think of an example here. Like, for example, like let's say you have a cluster, you have some computer science department that's doing a lot of machine learning. So you have, a bunch of GPU nodes that might run best with Ubuntu, for example. So you can configure a node image for that with all your drivers and all that stuff that work well for machine learning. But for something that's more CFD based, you might want to go with something like Rocky, and these CFD workflows typically run multi-node. So you want to probably have them running in MPI. And if you're doing MPI, you might want to have a interconnect like InfiniBand. And, those drivers would also be installed on your node image and get deployed onto these nodes as well. Yeah.
Thank you.
Yeah. And when it comes to, I guess, CFD in general is like an area that I have more experience in. And I think benchmarking, like figuring out performance for CFD workflows, I think is a little bit easier compared to other industry verticals. Compared to, like, for example, life science. I think my thought process on this is with the life science process, when you're doing like genomics analysis, there's a lot of lab prep that goes involved, which involves, sometimes a human dropping, chemicals into a microarray and then putting that into a sequencer. So there's room for error. Whereas if you're working on kind of just an engineering problem in a simulation, your variables are a lot more controlled, and the type of simulation you're running can also be extrapolated a lot easier. And this is because within a simulation, you're kind of simulating over a specific time scale. So for example, let's say I'm doing a 10-second simulation, and I want to benchmark how well this would run across these different, hardware configurations, for example. You can scale down that 10-second simulation to 1 second, run that 1 second simulation across all these different configurations and find which one gives you the best cost performance. And from having that cost performance, you can kind of extrapolate what this would look like on a 10-second simulation and figure out if that meets your business needs, and see how that actually affects your bottom line. And this is important when it comes to spending your grant money, or you have a budget allocated to your cost center, that you want to make sure that the workflows you're running actually meet that budget, and you don't want to blow that budget. Cool.
Well said, Brian. Well said.
Cool. I think we have another question.
Yep.
Yeah.
Where is that? In the YouTube?
Yes, right there.
Most of the national labs have chosen Alma Linux for security requirements. I don't know if that's accurate, but we'll go with it. I wonder what Rocky Linux needs to do in order to comply with federal compliance.
I think we just need FedRAMP.
What?
FedRAMP certification, and which I believe is, well, we're currently working on FIPS, and yeah. And I believe what is needed there is probably just FedRAMP compliance. And once we get that certification, I mean, I feel like we could be deployed in national labs a lot easier.
Yeah, and I will say we are being deployed in a lot of national labs at very large scale already. So love to talk more about that, Sumit, if you'd like to.
Yes.
Reach out to us.
Yes. www.ciq.com. You type in anything there, you put in your email address, that will come to me and I will respond to you. And then we can chat more about what your actual use case is, where we are at in terms of compliance and FedRAMP and all other types of security things. Because that's on our radar. We want to do that, right? Like the whole point here is to be responsive to our customers and our clients and what people need. So if there's something that you are curious about, I'd love it. Bring it to us and put it on we'll either let you know it's already on the roadmap or, it brings it to our attention. So we very much appreciate that. Okay,
Absolutely.
Brian. So you actually said something, and I know that's probably, we might be wrapping up here, but you said something about, God, what was the word that you used? Like monitoring, right? Where you said that you could have reports back. You said something about reporting back to your, superiors or whatever, like of what's going on in your cluster and how it's working, and either if it's speed or efficiency or whatever it is. So how do you get that information?
So I guess from a Slurm perspective, because your so accounting data within Slurm Slurm basically stores accounting data and job performance data within this database. There are a lot of tools that allow you to kind of visualize this data and also potentially generate reports, and allows you to kind of really look at your jobs and understand if they're performing efficiently or not. Most of that information can be pulled from Slurm. And basically, I think from the perspective of like management, like CIO, for example, might be interested in just the jobs that are running and the value that they're delivering, and maybe not so much the low-level performance details of the workflow, where I feel like that type of data the scientists might be most interested in, so that they're able to get their results the fastest. And, things that you would look at are, maybe your memory usage, the IO on these jobs, stuff like that, and understanding where these bottlenecks are so that you can remove them to get peak efficiency in your workflow.
So is Warewulf able to identify clearly and feed you back the information of what's going on each specific node?
Not necessarily. I feel like Warewulf is mainly responsible for provisioning the actual node itself, but getting that data from the node, you could use various tools, like various monitoring tools, like Prometheus. Some users use XDMod. So just different types of monitoring tools to actually get that type of data. But Warewulf will basically just provision the node for you with those services on it.
Mm-hmm. Cool. Very exciting.
Cool.
Anything else, Mr. Zane? You got a question?
I'm just watching the comments. There's another question that just popped up.
Cool. Are you seeing most customers building MPI inside of their Apptainers or using hybrid mode?
I feel like maybe at the moment more so inside the container, but I feel like the solution that the solutions architects at CIQ have been pushing is the hybrid model. So that is the method we would recommend. But if you don't know how to do it, I believe there are blog posts that we have that go through how to do that. So definitely recommend checking that out.
Do you want to give a real quick why you would choose to go that way, Brian? Why hybrid makes more sense from our perspective?
So using the hybrid method, I believe you're basically just using whatever is available on your system. So you as a user do not really need to care about installing OpenMPI within your container. And when you're using the hybrid model, I believe it's as simple as just running an srun command on the Slurm cluster versus it's basically just running an srun command if everything is configured correctly on your cluster. And that just makes it a little bit easier on the user if you're not familiar with MPI. Running an srun command is a lot easier than figuring out MPI, in my opinion. Yeah.
Thank you for that.
Yes.
Okay. Are we good with questions? Answering all the questions? And if something more comes up, you guys are watching this not live, or like 5 minutes later, something comes up, feel free to either put it back into the comments right here, which is fine. We check them periodically, and or go to our website, ciq.com, and submit a question there. We are more than happy to either answer right away or go and research and find the answer for you, or work together with you for an answer, because sometimes that also needs to happen.
David Rush has a question. Thanks for joining, Dave.
Sorry?
It's always good to see your questions.
Dave Rush, what's up, man? Is there a performance difference between hybrid versus dedicated MPI with containers? I think didn't we do a webinar on that? Like we had like graphs and charts and stuff, didn't we?
I feel like Jonathan did.
Yeah.
Dove into this a little bit, but that's been a while. Maybe it's time to refresh that one. Jonathan, instead of making coffee, you can go refresh this. I'll wait, see how long before I get a Slack message. Hold on.
Right. Do you have a response for that, Brian?
I'm actually not, off the top of my head, I'm not sure if there is a performance difference, but I would have to review. I believe Jonathan did do some work on this, which I would have to review before I speak more confidently on this topic.
Yeah, we'll find the link for you too, Dave. We'll find that link for you and pass it on, because I remember this happening, and it was cool to see the charts and kind of have him explain the testing that he did around that. It was nice.
It was cool. And yes, Dave, we will post that again, so you can go right to it.
Yeah. Cool. Okay, so whether you're like running genomics, am I pronouncing that right? Genomics?
There you go.
Genomics.
Potato,
okay.
tomato.
Potato. You're at a university, whatever is happening, you got an on-prem cluster that you are wanting to make sure is provisioned properly with some help and support. I mean, that's kind of one of the cool things about CIQ is that all three of those are open source initiatives. So the Rocky, the Apptainer, and also Warewulf. And then we come in as an added value, a resource. We're like, okay, this is your specific environment. This is what you need. And this is what your hardware is. This is what you're working with. This is where your security, your storage, your all the things. And we come and help you figure that out, how to set that up properly and get your cluster up and running and then supported. And it's nice to have one place to call that really has engineers working in all of these different initiatives. It's our customers that we have engaged in these sorts of relationships, helping build out the cluster. So thank you, Brian, and the SA team and all the engineers working on it. It's really been a cool thing, because, I mean, you know what it's like. If you're out there and you're like, what am I doing with my cluster? It's like, oh my God, what am I doing? And to have that kind of like help and support and somebody to call who's on a team working on your specific environment, just priceless. Well, we actually do. We can put a price on it, but it's priceless, and the way of it feels good. So are there any final thoughts that you want to share about clusters, Brian?
No, not really. I would just like to call. I'm going to be at FOSDEM 2024 next week, and also CentOS Connect in Brussels, Belgium. So if any of our viewers are attending and want to talk more about Warewulf, Apptainer, Rocky, I'm happy to talk more at those conferences. So
fantastic.
Yeah,
it's awesome.
Dang, Brian, living large.
Yeah, no kidding. Stay tuned on this question
Ooh.
on a GUI for Warewulf. I actually had a conversation about that this morning, so stay tuned.
It's coming, Sumit. It's coming. Yes. And again, thank you for pushing that, because the rest of the team who's working on that sees it, where it's like, yes, this is something that people are asking for and that they want. So appreciate that. Cool. Okay. Well, I think it's time to wrap up. You guys, HPC clusters, boom, boom, boom. I think Jonathan only had 2 cups of coffee. Brian, you are absolutely amazing. Appreciate your time and your energy. You guys, we are here to talk about clusters and help you build them out, answer all of your questions. We love you. We want you. We need you. We'll see you next week. Same time, same place. Make sure you like and subscribe and check out our podcast, Flops and Threads. Have a great day. Bye.
Thanks, everybody. Thank you, Brian.
Later.